here we are in the BC AP Calculus exam review book, chapter 7, page 196, and we're starting with number 4. It's asking, given this function, is L or M greater or equal? Like, what's the relationship? I'm going to tell you just based on the graph. So L is the area from 0 to 1, and this does go to infinity. And then M is the area under the curve from 1 to infinity, which also goes to infinity. Just based on looking at the area, I guessed that the answer was the L is less than the M, just based on looking at the area. Would you agree? Even though this goes to infinity and this goes to infinity, you can see that the M area started out way bigger than the L area. Now, I would like to just say that and move on, but I think we should do the algebra to review these improper limits. Improper means when one of your limits is infinity. Oh, I just lost my place. Okay, so let's look at L. So L is equal to the integral from 0 to 1, and this integral, I'm actually going to change this to k times x to the negative 1/2 to integrate. So it's really good practice of our simple power rule. K is a constant, so it just goes along for the ride. And we're going to add 1 to this power. So negative 1/2 plus 1 is 1/2. And to divide by 1/2, divide by our new power, it's actually multiplying by 2. And we're going to substitute in 0 to 1. So what do I have actually? I actually have 2k times the square root of x from 0 to 1. And we're going to do top minus bottom. So 2k times the square root of 1 minus 2k times the square root of 0. The square root of 0 is 0. And so we're left with L is equal to 2k. We're going to leave that there. Now let's look at M. M is the integral from 1 to infinity. So it's the same integral, we're just evaluating it two different places. So I'm going to skip this step and just write 2k times the square root from 1 to infinity. It's going to be top minus bottom. So we have 2k times the square root of infinity, fun, right? Minus 2k times 1. All right, so which one's bigger? If we have this is equal to M and this is equal to L, how would you determine which one's bigger? I mean, this is 2k times infinity. So this is actually could be rewritten as infinity minus 2k is definitely bigger than 2k. So that's why M is greater than L. Oh, I think it was written like this actually. All right, let's jump on. Let's move on. Multiple choice. Once you got the answer, you move on. So number 5. Number 5. There go my lights. Will it adjust? Let's see. Sorry for the video. Here we go. Okay. Number 5. I think I have this. Do you agree? Let's double check. Yeah. What's the area of the region in the first quadrant between the x-axis, the y-axis, and x equals 1? So we're going from 0 to 1. It's just there's a limit here. This is actually going to infinity. So we need to rewrite this as the limit as a approaches 0 from the right. So as we go towards 0, what's our integral going to be? I have room. So we're going to integrate this by adding 1 and dividing by the new power. So when I add 1 to negative 2, I get negative 1. So this is going to be negative 1 times x to the negative 1. And we're going to evaluate that from a to 1, which means we're going to plug in 1 and plug in a. So here we go. So when we plug in 1, we have negative 1 over 1 minus the limit as a approaches 0 from the right of negative 1 over a. Okay, as a approaches 0 from the right, look at the picture. Where is that value going? As you go from the right, as you go here, what value is this approaching? So since that is approaching infinity, this is negative 1 minus 1 over infinity. And we know that 1 over infinity, actually, excuse me, positive, positive, positive. 1 over infinity is 0, so the answer here is negative 1. Number 6. I'm still here, just thinking. Okay. Number 6, do you see how it's rational with two factors here? So what we're going to do is we're going to use not integration by parts, that's u and v. We're going to use partial fractions. I hope I can fit it on this paper. Partial fractions is where you split this up. So we're going to have, are you ready? We're going to have, let's see how teeny tiny I can make this. 4 over this is going to equal a over x minus 3 plus b over x plus 1. And when we don't want it to be a rational equation, so we're going to multiply by the denominator to get 4 equals a times x plus 1 plus b times x minus 3, because we multiplied everything by x minus 3 times x plus 1. Now when we choose, what are we going to choose first? This right here, what would make this 0? Negative 1. So when we choose negative 1, we're going to get 4 equals, well, what is negative 1 minus 3? Negative 4. So 4 equals negative 4 times b, so b equals negative 1. That's when we eliminated a. Okay, now what are we going to choose to eliminate b? We're going to choose 3. So 4 equals positive 4 times a, so a equals positive 1. So that you need to do quickly. That's not even the calculus. That's just, we need to get to the calculus. So we're going to rewrite this integral. It did it have limits? No limits? Yes? No? No limits. Okay. So we have, instead of 4 over this is going to equal, what's a? A is 1. A is over x minus 3. And b is negative 1. And b was over x plus 1. So that's that. Now we're going to integrate this. Both of these are logarithms. So it's going to be the ln of x minus 3 minus the ln of x plus 1 plus c. We're going to make sure sometimes they do something funny with the minus sign, like change it to a division. And I'm wondering where that 4 came from. So, we're going to figure this out, you guys. So, it's not that. It's not A. It's not B. It's definitely not C. So I'm wondering if it's D or it's a typo because this book is stupid. All right, so yay, we did the math correctly and the book is stupid. We confirmed. This is a typo, so we're going to do, anytime you subtract 2 logs, you can combine them into 1 log by dividing, and that answer isn't one of the answer choices. They said it was answer B, but it's not. So, ta-da, number 6, done. Here we go. Number 7, rocking this chapter. What is the area of the region in the first quadrant between the x-axis and that graph? We will see, right? Area equals, what are we doing? We're starting at 1, and it looks like we're going to infinity. And it's 1 over x squared, which we're going to write like this. Okay, so finally we're seeing problems repeating where we're practicing the same thing. So let's see. Add 1, divide by the new power, and evaluate from 1 to infinity. Here we go, here we go. I'm going to rewrite this as negative 1 over x from 1 to infinity. Is that right? Yeah. And what are we going to do? Plug in top minus bottom. So negative 1 over infinity minus negative that. What's 1 divided by infinity? Always. It is 0 plus 1 equals 1. I'm going to check my answer. That was number 7. See you guys? You can do it. They're not all difficult. Let's check the answer. Oh my goodness, we got it right and the book got it right. Congratulations, everyone. Number 8. Let f be a differentiable function with the properties that f of 1 equals 5. I'm reading from the book. Okay, so that's an initial condition. The limit of f is negative 8. Hold on here. Limit as x approaches infinity. That means it's a horizontal asymptote. I wonder if that's a clue for us. Find this, the integral of the derivative. Okay, we're going to try this. Here we go. How do we integrate a derivative? You guys, I don't think this is that hard. I hope not. Let's go. This is going to be f of infinity minus f of 1. What's f of infinity? Well, if you let x go to infinity, we get negative 8 minus, I feel like there's a trick. I feel like they're teasing us. Did everyone understand this? That the antiderivative, here, maybe I skipped the step. The antiderivative of f prime is f, so that's the antiderivative, and we're going to evaluate that from 1 to infinity, which means we do top minus bottom, and that's what I got. Hip hip hooray. Looks like we're doing it right. Isn't it funny? They're kind of getting easier, right? Number 9, the area of the region bounded by those graphs and the x-axis is, can I use a calculator? Because what's the most important part about doing area is that you need to know, oh, that's not it. We need to know what's on top, oh, and what's on the bottom. Oh, we don't need to know that. Oh, people. I just don't like how this is looking. I want it to be beautiful for you guys. How am I doing on time? We're doing okay? Okay, this is the graph, and we want to go from x equals 0 to x equals the ln of 2. That's a number, you guys. Oh, and the x-axis. So here we go. Area equals 0 to the ln of 2. X times e to the x. Okay, what's it called when you have a product? When you want to do an integral of a product? That's going to be integration by parts, where we have u and dv. And we're going to take a guess. Watch me guess. I'm just going to guess x is first, and so the derivative of that is dx. And I'm going to make dv e to the x, and the antiderivative of that is e to the x. So here we go. What starts off here? U times v. You can pause if I'm going too fast. I just want to make sure I finish this number 9. Minus v du. And we are evaluating this. Let me integrate first. What's the antiderivative of e to the x? E to the x. So it's no plus c because we're actually going to plug in 0 and ln of 2. Careful with 0, it's not going to be 0 for ease. Now, I'm not going to have enough room on one line to do this, so I might continue on another line of the paper. So here's top minus, this is me plugging in 0. Okay, let me come down here. ln of 2 is ln of 2 times e times ln 2 cancels, and we're left with 2. I'm running out of time. Minus e times, that's going to be 2, minus, this is 0, but negative e to the 0 is 1. This is what I have.